Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome back with me. My name is Ocviona Putri and I'm from the B class chemistry on University of Islamic Maulana Malik Ibrahim Malang stage. Okay, and now I will to present about the chemistry environmental material with the title is aeration and wastewater treatment. So guys, let's get started. This is the first. The definition of aeration. Aeration is a wastewater treatment process by adding oxygen or air to the water by bringing the air and water into close contact. The purpose of the wastewater treatment with aeration system is reducing levels of carbon dioxide contained in wastewater, increase the amount of oxygen so that the oxidation process and bacterial decomposition are maximized, and eliminate chemical compounds that can affect the smell and taste of water, such as methane, hydrogen sulfide, or other compounds that are volatile or evaporate in water. Wastewater treatment with aeration system has several important functions, namely minimize the presence of contaminants in the water, occurrence of the process of circulation oxygen at the top with the bottom of the water, and then move water more quickly the areas that have not accurate aeration, and the last, dissolve oxygen levels directly in water. Several factors determine to the good or bad wastewater treatment, oxygen transfer by the including oxygen saturation, water temperature, degree of water turbulence, and characteristic of treated water. And then the wastewater treatment by aeration divided by two types. Like number one is naturally and the number two is artificially. This is the example for the number one and this is for the number two. So next, naturally aeration. Water formed on ocean waves is an example of a natural form of aeration. When the waves hit the land on the beach sand, it has something to do with his seawater aeration system. The wet and smooth beach sand is due to the sea water which is contained ionic salts such as sodium chloride, magnesium chloride, potassium, natrium, and kalium, and H. So, when ions meet at sea with the air or and oxygen, then an aeration system will occur. And this phenomenon is very beneficial to the um, any biota in the sea. Like there can to live with the oxygen for the air. Okay, and the number two, artificially, about the wastewater treatment process using the artificial aeration method. In general, to aerate wastewater, a device called an aerator. This is the picture about the aerator. Um, During the aeration process, is the oxygen will be supplied by the aerator is a certain amount to meet the need for aerobic bacteria that function to decompose wastewater to make it safe for the environment. The addition of the oxygen helps to decompose microorganisms to decompose organic substance better. Okay, this is the various type of aerator. The first picture is a surface aerator. It can to be industrial, and this is turbo aerator. Uh, this this machine is more than biggest more than a surface aerator, and number three is a tubular aerator. This air is turbulent in here, and then with the air on the several several leaf so in the environment, and then it to be around and make a foam to make it the color in water. Okay, this is the fun fact. FYI, the coral reef that was hit by the big waves of the sea made it even stronger. This is because the salt and alkali ions contained in seawater stick and trace on coral. The form of dissolved ions in the wave water that hits the coral will collect and settle to form solids. So, the waves of the sea, if it hand the coral, it make the coral then more strongly. And this phenomenon also occurs in the physically form of clamshell. The longer they are in the sea, the have a harder they will be. Okay, this is the part two. How about wastewater treatment? Use aluminum sulfate and the chemist shape is Al2SO43. So processing using chemical aluminum sulfate. Processing using chemical aluminum sulfate Al2SO43 are commonly called alum and Fa2SO43. Then working of alum, namely as a coagulant that attracts pollutants and impurities, is collided with water. Step of water treatment with the alums. The step water treatment first is we can take a samples were taken from the urban areas and the placed into beakers. The right side, uh, sorry, the first beakers is use the alum and the secondly bakers is not use alum just naturally, so we can divide we can compare how about the first bakers, then the secondly bakers? One goes without alum and the other without added. And of course, the clear is the sample that is given in alum. Because what? Uh, because alum can be the alum mechanism progress is how there is make a colloid is to uh, colloid is make settlement in the bottom of beaker, and the secondly, after that the water is filtered again to make it clear. The working principle of alum, which is able to collect dirty alum here as a coagulant. Previously, the colloid system always repel because the change is the same after a coagulant will be settled, so that the colloidal system is always stable to repel each other or continue to be cloudy. So then the coagulant is given and a text can be layered and it will be two cell environment. Okay, um, the wastewater treatment divide into two types. The first type is the water to be discharged into the environment. This picture for the number one. I have a mistake for the take the picture, and then this is the water from the consumption of our leaf. This is the picture how to we use the we use the water for to live our leaf, and it was so important um, to reducing or to make it a new version. And step two is water treatment consumed by the four step. The first step is screening and coagulant population, and then clarification and sedimentation, and the last part is filtration. So the first step is screening. This is step when the water is to filter or sort out the form of wastewater to be processed. And And then, after baik is given aluminum sulfate and assisted by stirring, the interaction increases so that it is easy to be settled. So in this part, aluminum sulfate or Al2SO43 used to wastewater treatment with a okay, the coagulant or flocculation, this part when the aluminum sulfate is the important role. So it make the interaction when the increase the quality and that it easy to make it settle in the bottom of the beaker. And then the next step is the clarification or sedimentation. Here is the settling column for collecting salt. They move very slowly to be deposited. And the last part is filtration. When the air pass of the coagulation screening and clarification, it come to be filtration. In this part, use the sand to be a filter because it's the fast then the speed of the water is made very slow. The sand serves to filter and bind with the absorption events. Again, this is the video about the wastewater treatment with the coagulation and fluctuation. Use the material is aluminum sulfate or Al2SO43. This material is generally to you to using for the industrial or anything else make to filtered by the wastewater. Okay, guys, let me see together how about this video. Coagulation is the addition of chemical to the liquid and then electrostatic force of unsuitable solids. Coagulant chemicals typically have a positive charge which binds to the negatively charged particles in water, neutralizing them and allowing them to come together for the small clumps of particles called microflow. In most cases, the chemical reaction occurs in a fraction a second, so it's important to coagulate is dispersed quickly and evenly and encourage as many particle coatings as possible. Because this process relies on chemical reactions, several considerations must be met: water temperature, for example, colder water and usually slow. Coagulation and flocculation reaction, which may require more time to achieve optimal formation. Extreme values of pH, high or low, will also interfere with the process. Coagulant effectiveness is highly dependent on pH. For some coagulants, alkalinity is a factor. Operators may need to raise alkalinity for a coagulant to be effective when using iron or aluminum coagulants that can consume alkalinity and depress pH. When they are added to low alkalinity waters, turbidity is also important. To lower the turbidity, the more difficult it is. From copper fluid, the most common coagulant chemical used is aluminum sulfate, commonly called alu. When added to water, alu forms jelly-like particles of aluminum hydroxide. The trivalent aluminum ions neutralize and attach to negatively charged particle in water forming micro. For aluminum works base is a pH range of 5,5 until 27,5. Polyaluminum chloride and iron salt is ferric chloride and ferric sulfate are also used. They operate over with pH range coagulant and flocculant and are added to improve binding protein stronger when suitable floc and evade flocculation by increasing floc size strength and or floc density. In addition, they help overcome the odds of low temperatures, reduce the amount of coagulant needed and reduce the amount of starch produced. Commonly used coagulant polymers may be Polyelectrolytes such as the water-soluble flocculants water insoluble ion exchange resin and uncharged materials. Polymers are long chains of molecules that produce highly charged ion and help bond microflux together into large flow particles. They are very popular with the predators because they're very effective and can be positive, negative, or neutral, each charge providing a great deal of flexibility in different circumstances. Okay, there's the video, and I say sorry if I have something wrong in this part video. I take video because I'm just a student and we stay to learn together for the my language on my or I'm sorry if I have something wrong mm, but by my language speaking or my material presentation. Uh, Thanks for your attention and I say sorry again. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.